All right, so that will give us a number. It doesn't always come out neat and nice like that, but that is one way that it does work. What would y'all do with the 1/2? Okay, so we have 16 to the 1/2 times 9 to the 1/2. They're not like bases. I can't do anything that way. Do you know how to write this in radical form, like in the first one? No. Phone a friend. Ashby? Square root of 16. What would this be, Hunter, in radical form? What's the square root of 4, Wes? Shoot, I hate when I give the answer. What is the square root of 9, Wes? Why is it not plus or minus? What was the original problem? Simplify. It wasn't a solve. Now the air conditioning's on. It's like 19 degrees out. Okay. Ask your question again. All right, let's compare the original question to 16 plus 9 to the 1/2. When there is a plus addition or subtraction in the middle, it does not act like multiplication. You cannot give the 1/2 to each unit. What do you have to do first? You've got to add them. That's right, Keandre. In the parentheses, you must add them first. Now, Lakin, how do I turn 25 to the 1/2 from exponent to radical form? Good. Is what? Good. So you do attack those two problems totally different. Sixteen times 9 should be what? And so it works either way in multiplication. But in addition, you can't do that. Do you get that part? Like why I showed you? All right. Shh. Ladies and gentlemen, my son and I had this conversation over the weekend. He said, Mom, I have the teacher who can do the loudest shh. Like I didn't do it loud because I have this thing on. He said, how many times do you say shh? I said, I never have to say shh to my students. They're so awesome. I know I've said shh 4 times today already. That's what I get for bragging on you and being like, I never have to tell them shush. Ever. They are so polite and respectful. I didn't. Ooh. What's the problem with this little guy? They have like bases, but they do not have like denominators. So when you try to do 5/3 minus 1/2, some of you still do not know what to do with that. So what are you going to do when you get a problem like that on the homework or test? Be confused is not the answer, Harrison. Was Harrison right? (10/6) minus 3/6 gives us 4 to the 7/6. So you can use the calculator and get it. It will get it just as well. Or you may do it the long way, find a common denominator, and get your answer in that way. (27/64) quantity to the 1/3 power. First, how could you rewrite this as a radical? Emily, will you do the numerator for me? What is it? Okay. Where does the index go and what's the number, Spinda? Where does the 3 go? Good. How about if Haley tells me how to rewrite 64 to the 1/3 in radical? Good. And it does have a power of 1, but you all have to write the power of 1 because it's there. We just haven't been writing it. Is 27 a perfect cube rootable number? Is 64 a perfect cube rootable number? Yes. How could you rewrite this radical as an exponent? How could you go backwards? Kelsey, do you know how to go backwards from a radical to an exponent? Just do that part. Perfect. 7 to the 1/3 power. The absence of a power, she just put placeholder 1, and that's fine. How about this one, Britta? Rewrite that as a power. Now, to use the multiplication rule, what has to be true about the bases? Right. So, Madison, can you write 49 as a base 7? First strategy, see if it's divisible by 7. Is it? Then you have to decide, could that be written as a power? So we know it's divisible by 7, but can we write 49 as 7 to some power? So try Madison 7 to the first. What is 7 to the first? Just 7. Then go 7 squared. What's 7 times 7? That's adding. 49. Yes, there you go. So it does work. You just have to have a strategy to kind of figure out, once it's divisible, what the power is. All right, so now I have like bases. I have 7 to the 1/3 times 7 to the, remember, 1 base, 2 powers, power to a power. You got to multiply 2 times 1/3. Now what would you do, Savannah, with 7 to the 1/3 times 7 to the 2/3? You write the base once. She told me to add the exponents, which I did. So what is my solution? 7. Now, could we have gone a totally different route? What is 7 times 49? Somebody do that in their calculator. What's the cube root of 343? The problem is, does that always work? Look how much work we did here, and look how little work we did here. If it's multiply and they have the same root, you can always put them under the same radical. But if it's addition, you absolutely cannot, and you must be super, super careful with that. Yep. Just does not always work out that pretty. All right, we have the 5th root of 5 over the 5th root of 27. Now, do any numbers go into 27? Does it have any factors besides 1 in itself? 3. How many times does 3, let's talk about what we did with Madison a minute ago. 3 goes into it. So 3 to the first is not 27. How about 3 squared? Nope, that's 9. How about 3 cubed? So I'm going to write 27 as 3 cubed. Now the reason I wrote it as a power of a number is because the only way I can rationalize the denominator is if my root matches my power. What's wrong here? How many short am I of having a match of 5 and 3? How many 3s short? 2 3s. How can you write that in abbreviated form? The 5th root of 3 squared. But if I put the 5th root of 3 squared in the denominator, where else do I have to put it? Good. Now what Ashby just said was, so if they have the same root, you can put them under the same radical. Did I just use what she said in the numerator? I did. Because it's the 5th root of 3 squared, I can put the 3 squared also under the 5th root radical in the numerator. Now, why did we do that? Because you cannot leave a radical in the denominator. In the denominator, we now have the 5th root of 3 to the 5th. In the numerator, we now have the 5th root of, is it 45? 9 times 5? Yes. Why did we do that? Like, why did we go through that? What is our goal in this question? Right, it just says simplify, but we have got to get rid of the radical in the denominator. Now, what happens, Chloe, to the 5th root and the 5th power now? Perfect, they're going to cancel for us. So we have the 5th root of 45 over 3. Now, do we have any perfect 5th roots as factors of 45? Okay, 1 to the 5th is 1. What's 2 to the 5th? Somebody do that real quick. 42? Oh, I was going to say that doesn't sound right. 32. So that's not going to go in there. How about 3 to the 5th? That ought to be a big number. I can't do it in my head. What did you say it was, Britta? 243. So do we have any numbers that are perfect 5th roots that are in there? So how do I know I'm done? Because there's no 5th root factors in 45. If this were 64, you would have to do something. So let's leave that guy and let's fake an answer. This is a fake answer. We didn't do a problem. We're just making up a fake answer to a problem. If we have the 5th root of 64 over 3, why would we have to do something again? We just did our strategy. 1 to the 5th was nothing that would help us. It was 1. But what was 2 to the 5th? 32. So if I were to write this as 2 to the 5th times 2, where did I get that 2 to the 5th again? Yeah, the factor tree for 64 is 32 times 2. So what did I rewrite 32 as? Not something hard. What did I write it as, Caitlin? 2 to the 5th. And how did I even know I could do that? I tested them. 1 to the 5th, 2 to the 5th, 3 to the 5th, 4 to the 5th. I tried a few to see. Now, what would simplify here, Riley? Anything? Now here's where you have to be careful. Riley's exactly right. The 5th root of 2 to the 5th will simplify. What will not simplify, Riley? The 5th root of 2. It doesn't go any lower. It doesn't have any factors in it. All right, so Dylan, what would I do with what Riley said was a match, the 5th root and the 5th power? Yeah, they're opposite operations. Cancel those out. You have 2 times the 5th root of 2 over 3. Is that ugly? Yeah. It was almost better that nothing went into this 45 because we could stop instead of having to do that one more step of simplifying. This one you might want to put a star by it because it is in your homework, that one. It is an exact question in your homework. What if we, go ahead, Harrison. This guy right here. Not the fake answer thing. I just did that to show you something. All right, let's simplify. Oh my goodness, Miss Walter is putting radicals in the exponent position. We have one base and two exponents. What do you do with them? See if that will simplify. What is the square root of 2 times 3 square root of 2? Three times square root of 4, and the square root of 4 is 2, so Wes is right, x to the 6th. Now these did not start out rational. They started out square root of 2 is irrational, 3 square root of 2 is irrational, but once you multiplied them, then you went back to not just a rational, but an actual integer exponent. The third root of 5 plus 6 the third root of 5. Is that doable? Let x be the third root of 5. So go from here to here. Is that question doable? What do you think, Madeline? Can you add x and 6x? What would you make them? Good. Then, it's not x. What is it really? Third root of 5. So what are you going to put there? You really have not 7 x's, but we let x be the third root of 5. So you have 7 third roots of 5. In the old days in middle school, how many times would you have had to written this? 1, 2, 3, 4, 5, 6, 7. How many third roots of 5 did you have? Nobody wants to write that out, right? So that's why we have 7 third root of 5. Because it's literally saying you have 7 of these x's. Well, what were the x's? 3 squared of 5. You don't ever have to do that step, but I wanted to put it in perspective. How easy is x plus 6x? 7x. This is that easy. Let's simplify. This looks impossible. Why does it look impossible at first? Right, we have a square root of 2 and a square root of 18. In order to add them or subtract them, they have to be alike. Do they appear alike? Rob, give me the factor tree for 18 that includes a perfect square rootable number. Yeah, he said like 9 and 2. He's exactly right. So could I change 18 with no penalty, the square root of 18, into the square root of 9 square root of 2? Yes or no? What simplifies here, Tate? We have 3 square root of 9 times square root of 2. What simplifies? The square root of 9 becomes what? All right, so Rachel, what do I do with 3 times square root of 2? Is there any way to make that better? Yeah. Now, once I get there, Erica, what do I do with 9 square root of 2 plus 4 square root of 2? Erica. Only the coefficients. Why? Imagine again that I let x equal square root of 2, okay, just for a second, Erica. That would give me 9x plus 4x. So how many x's would you have if it weren't that, if it were x's? How many x's would you have, dear? No, that's not what I mean. If I were to write it out the long way, how many x's would I have on this side of the plus? 9. How many x's would I have on this side? So I would write x plus x plus x over and over again. How many times? Right. And then when I add those together, how many do I have total? Perfect. Now, she said 2 x's because she's just saying, oh, I see an x and an x. We really, though, have how many, Erica? 13 of the x's. Now, if I go back and put that back in the equation, I have 13 of what? Not x's, but what are they? Square roots of 2. So do not, Erica, let it mess with you that they're square roots of 2 because they act just exactly like what? X's. If they're not alike, can you put them together? If that were an x and a y, could you put them together? No. All right, 13 squared of 2. And how did we attack it? Because at first it looked like they couldn't even go together, right? How did we attack it? We checked to see what, Emily, in 18? Because if there was a perfect square root in it, 2 is as prime as it can get. It's got the factor of 1 and itself, and that's it. But we checked 18 to see if there was a factor that was a perfect square root. Good. Yes?
Is there a case where you could actually add a radical, add two square numbers?
I don't know. I'll think about that for a minute. I don't want these numbers to match. I'm going to change that to a 14. 14 over the 4th root of 11. Not much to do here. Does anybody have any idea what they would do to get rid of the 4 so they could rationalize the denominator? How many 11s do I have? 1. How many do I need? 4. Dylan, what could I put under that radical to make that work? How many 11s more do I need? 3. But if I put them in the denominator, I also have to put them in the numerator, correct? So my numerator is just ugly. It is 14 times the 4th root of 11 cubed. But my denominator is going to clean up a little bit. What's going to happen, Selena, to my denominator? How can I rewrite it? 4th root of what? Right. 11 to the 4th is perfect. What's going to happen, Kariah, to the 4th root and the 4th power, sweetie? They are. Good. So I have 14 times the 4th root of 11 cubed over 11. Cancel those. The temptation is to cancel him with him. You cannot do that. Do not do that. And can you take the 4th root of 11 cubed? No. The most you could do is say 11 times 11 times 11 and put that answer in there. But that's the most you could do on that one. Go ahead.